G'day guys. I'm persevering with this coil, the one I did the pull down on, this Minelab Super Gold Search Mono, because I'm going to fix it up and that. And I was thinking that, any of you guys out there could turn this into a business. You could make money out of it by refurbishing old coils and modernizing them, making them a lot better. It's not that difficult. You know, I'm trying to give you some ideas here about doing this. Now, a lot of people will think, oh God, I can't do that. I can't do that. That's what they'll think. Oh, that's beyond my pay grade, But it's not. You have to remember, even Einstein was born knowing nothing, right? And everyone is born knowing nothing. And you just have to educate yourself. You do not need to go to university. You do not need to, have a bachelor's degree or whatever, master's degree to make good money. Now, why I'm saying that is there's a lot of prospectors. Okay, now I've got to get into the mindset of prospectors. Prospectors are more likely to buy Tats Lotto tickets than not, okay, for the general population. And a lot of prospectors are dreamers, really, because that's what got me in, was it the dream of finding big gold back in 1980. That got me in, and then I sort of became a little bit more rational and went to the technical side of things a bit more, but I still go out there prospecting. That dream never dies. All you need to do is find one bit of gold and it fires it up again. But you've got to keep it level. Just keep it level. But what I'm saying here is you can get these old coils, okay? They're easy enough to pull apart. You've seen that in a previous video. And what I was thinking is, with this foam stuff, with this glue on the foam, that now if you want to put another piece of paper on there, it could flex between the glue and the foam a little bit, and it could sound off. And I thought about it, and I said, well, I tried every chemical under the sun to get the glue off. Nothing budges it. It will not attack it, right? And this is this crispy foam. If you can hear that, it's really hard, surfboard foam or something of that nature. Anyway, what I thought about, if you wanted to do this, just dig it out. It doesn't make any difference, and I'll explain why, and I'm going to show you why. Okay, you just get a screwdriver. Okay, I usually have my 4 eyes on and get really close to it, but I don't really need to. But see what I'm doing here, right? I can just go under it and mow it like from underneath, like something like so. I can do this. Get under there, and then just push it along, and off it comes. Right? There's many ways of doing it. Can't use a knife. It binds to a knife blade. So it doesn't make any difference how big the gouges are, within reason, of course, how far deep you dig into this. I could get this and, do that all over it. It's not going to do anything. It's not going to affect the structural integrity of it. It's just going to make some very shallow trenches in the foam. But you think, oh, that's going to have an effect. No, it's not. The foam's inert. It's only a method of holding everything together. And doing that, you go, oh, but it doesn't look pretty. Who cares? You're not going to see it. And it doesn't make any difference. It makes zero difference to the way the Faraday shield works, because you could put the paper back on and glue it down, but I'd rather not. What I'm going to do, I'm going to use the same stuff that they use for shielding guitar cavities. And I'll just show you how well this stuff paints up. I'm going to use Y-Shield, the commercial version, which I have lots of, and it's, like I say, it's 15 or 17 years old. It still works beautifully. There's nothing wrong with that stuff. It just lasts. And guys, if you want to do coil experimentation, I suggest suggest. That was just and suggest at the same time. This is why people edit their videos, I'm sure. But you know what I mean. Buy a big bottle of the Y Shield, the HFS 54, and buy a big bottle of the 34. And what I would do with that, I would do what I said in previous videos, mix it up and test it till you get a good resistance with the material dry, 80 ohms, 100 ohms, 150, 200, whatever. But anyway, this is how you can do this. Just make trenches. And because of the way this stuff behaves, it's not going to do any damage to anything as such. All you got to do is do what I've done here, right? And it didn't take that long. And if you really, really wanted to, you can get this stuff. And if you get a little horizontal wood mill, you can put this on a spindle, spin it around, put your groove in. If you want to, some of the mills can flick over, you can groove that, you can cut it out with a knife. It's not fussy stuff. But, some of the coils people buy are worth a fortune. Like I saw some of those X coils, and they haven't even got the dongle, and they want bloody near $3,000 for them. I mean, I'm thinking to myself, what? This is a license to print money. So if you had someone who spent that much money on a coil and it went faulty, wouldn't you want to fix it for them? This is something you can learn. It's not hard. Look at me. I'm just doing that, scratching it off. Can you do that? So can you pull it apart? Yes. You may find even better ways of doing it. Anyway, what I've done with this, the other side's still got that glue on it. That's easy remove anyway. It's no big deal. But so we'll get this, and all I want to do is just feel it and make sure it's got no high points. High points will rub through. What I would normally do here is I would get some very coarse sandpaper on a block and just kiss it off like so. It would be fine. I don't have any sandpaper here. Yes, I do. Well, that's very, very fine grade. But anyway, look, just sand it, whatever, no big deal. And what you do, when you get to this point here, just remember, you put a piece of masking tape across it and a couple of cross beats so it doesn't move in and out. And when you paint it, it'll also give it very, very good stability. But look, how about I partially paint this? I'll show you how I do it. So I've got my HFS 54. This is already modified, so I've got the right, about 120 ohms per inch. So I just mixed I just worked out the percentages. I can't remember exactly what it was, but you don't need much of that NSF 34 to make it down. I think it was something, oh dear, what was it? Somewhere between 5 and 10%, but I did it years and years ago. So this is like a pre-mixed batch. And like I say, if you get this stuff, guys, all put in for it and then divide it up, mix it and put it in containers and share it out. And the cost to each of you would be minimal. Anyway, what I'll do, I'll shake this up, because what I do, I shake it like how I've shook this already. But I'm going to get the stuff on top of the lid, right? And use the lid as a paint container. But make sure the lid's on when you do that. If you spilt this, it would be an absolute disaster, beyond belief. So don't leave it where you're going to elbow it or anything like that. Once you take the lid off, you should actually have probably a spare lid. But so that's that in there. I'm going to put this where no one's going to go near it, okay? Bar having an earthquake, we're safe. What else do I need? I need a paintbrush. And I had a paintbrush. What do I do with it? I had it. See, the trouble with this room is everything is just... Hang on. I've got to stand up to find it. Here we go. I always say this is like a a CIA spy satellite view down, trying to spot something you're trying to find down there, you know. Oh, there we go, found it. It just lays with the tools and you can't find your paintbrush. And here we go. So I've got the lid. Look, it's very easy. Just stick it in a paint there, which I've sploshed up onto the lid. And have a look at how well this paints. Beautiful. No problem. Look at that. That's nothing wrong with that at all. Perfect. I don't know why they don't. Well, some companies do that. So if we go in the grooves, right, in those little gaps there, I'm using a tiny brush just because I used to do a lot of painting, like art painting. And you get little holes in there. Not that it even matter if you didn't even fill it, probably. But, you know, that's what we're getting at. We're getting at a nice layer like that. That's your Faraday shield. And obviously you're going to use a wire on it and stuff like that. But rather than using the paper and putting this, you know, carbon paper back on it, you know, same stuff. If that dries, it'll be the same color. You can just do it like this. It's not that hard. This is pretty, you know, bodgy way of doing it because I'm using such a small brush and I'm painting it out of the lid. I mean, that's really being cheap, isn't it? But yeah, it'll work. I'll just give you an idea anyway. When you get to the edge of the coil, don't paint around the edge of the coil. Think this out. You got to think it out because you do not want continuity here. Oh, I think David's here. David's arrived. I think he's come in. See what he says when he walks in the door. I won't even tell him I'm making a video. We'll see what he says. I'm waiting. Sounds like small ones are trying to open the door. But anyway, what I would do for this anyway, we'll measure up, we'll let it dry, we'll see how many ohms it is. And if it's on the low side, what we can do, very easy, we just add another layer. But if you can see in here how all those, you know, like little Grand Canyons have been infilled, that's fine. It's not going to affect anything. Actually, maybe discontinuities in the Faraday shield may possibly even improve the performance. Do you know that? Maybe someone should try it. Have a whole heap of dips and valleys in the manufacture of these and have the Faraday shield up and down, up and down. I mean, it's giving it a lot more surface area because of the valleys, and maybe it diffuses some of the ground effect a little bit between the sharp points and the sharp valleys. This is stuff, you know, I think of as I go. I don't, and I haven't proved it. But basically, along those lines there. So just a little few drips in the lid's gone a long way. So you don't need much of this stuff. Look at that. So, you know, a few mil, you know, what is it for the Americans? What are we going to say it in? Fluid ounces. I can't remember what a fluid ounce looks like, but, you know, a quarter of a fluid ounce or something like that, maybe. I don't know. We all use mils because mils is very, very divisible and we can get very accurate measurements. You know, it's like millimeters and, you know, or centimeters and inches and things like that. You know, divisible by 10 is a far better way of going when you're dividing something. If you want my opinion, but we used to have I shouldn't even say this, should I? But we used to have a saying, right? And don't take it the wrong way. It's just funny. It's just funny because I have worked with Americans before when I was doing a lot of electronic work. Some of it I cannot mention. But what happened was we had this is basically English, UK, Australian joke. And we used to say something along the lines of, and even Canadians would say this too, right? If you want to confuse an American, give them a metric ruler, right? That's what we used to say. Because, you know, it's fair enough. They weren't used to metric. I'm talking years ago anyway, and everything. Even I was brought up on, you know, inches, pints, you know, whatever, those sort of things, ounces. But anyway, that gives you an idea of the painting. With this, you don't want to put it anywhere it's going to touch anything. Yeah, all the Americans out there are going to unsubscribe now because I said that. But it was just a joke. You can say, look, we ride around on kangaroos here. We walk upside down on the earth. How come we don't fall off? There's a heap of jokes out there about silly things. But anyway, and here comes Dave. Dave's come in, which I said he was here. Yeah, I'm just doing a rebuild on this coil. I was just showing how the glue, you can't get it off.
Which one?
The glue, you can't get it off. This glue.
Oh, it's horrible.
Yeah, it's sort of tacky as. And I just said, what you do is you just dig it out, flick it out, and because if you're going to make a painted shield, who cares? It's not going to have any effect. It's not going to have any detrimental effect anyway. So I'm just doing a little bit of a thing on that. Can you chuck us a meter? I'll just measure it. We'll see where we are ohms wise. It's not dry. This stuff goes lower in ohms as it dries.
So is that the 8-inch?
Yeah, it's one of the 8 inches. I'm going to redo this one, and then I'm going to compare it with the other one out in the field, so we can do a show and tell. But yeah, so okay. Where's the bit I did first? Somewhere around the middle, I think. Oh, look at that! It's above 2K. Work that out. It's probably because it's not dry. Now the meter is working. It's probably because it's not dry. That's all it will be. When it dries, it goes really low in ohms. So there's some mechanism there. That's amazing. It's like, yeah, I've got black paint all over my leads now, but it does need to dry. What I'll do, I'll just let's put a bit more on. I have to use the right stuff, haven't I? The 54 is the low stuff, isn't it? Yes, 54. It'd be funny if I actually got the numbers muddled up and put on this stuff and it was all like 1,000 ohms. But yeah, I'll shake it up. That's really, really strange. It always does that to me right in the middle of a video. You can say, oh, that'll be da-da-da, and it's not. No, I shouldn't do this inside the house. It should be out in the garage, but there's a Land Rover in there at the moment. I can't do that because, yeah, Dave wants to fix it up and, yeah, sell it. Come on, people, if you want a Land Rover, Disco 3, that worked really well, actually. We put a new air pump on it for the air suspension. Make an offer. Oh, dear me. Anyway. Now I'll probably paint it over where it was drying and it's going to be more wet. But anyway, we'll see how we go. But painting foam as well, because it's got a lot of little up and downs, maybe this causes good discontinued. What do they call it? Discontinue. Oh God, I'm tongue tied. Like is discontinuarities? Is that a good word? Exactly why people edit their videos. They don't show paint going everywhere, and if there's clangers in the video, they're all edited out. But I don't edit. I might have said something. I might have to bleep it out actually in the video. Damn. There's nothing worse than this stuff. Yeah. Anyway, I'm using a tiny brush and yeah, doing it like that. It's not the way you do it. I'm just doing it. It's just a show and tell. Okay. So, dear me. Even now, it should actually read something. It's ridiculous. It does on everything else. I really think it wants to dry. It just, oh, there we go. I saw a flash of numbers there. But yeah, when it dries, it massively drops in ohms. I could speed it up by hitting it with a hot air gun, but you don't really want to do that. Um, Maybe I just do that, but you get the gist of it anyway. I mean, this stuff is relatively low ohm, so that shouldn't really have any effect on the end result. It should be like, have a look at this stuff. This papery business. If I go on that, I'll put that a bit lower. But if you go on here and you go sort of like somewhere around there, I can go lower again. There we go. Have a look at this. Okay. 60 ohms. Okay, 60 ohms. If you can see that on the meter over there, 63 ohms. Even right on the other side, 128. It's an arbitrary figure to a degree. You don't want it so low that it burns up energy. You don't want it so high that it's ineffective. Now, if we have a look, that was the bottom part. That's the one wasn't it? No, that was the top part. That was the top part. So I'll just put on the bottom part here. I was going to tell you something about the bottom part too, so I'll put that on there. It's the same. Yeah, 50, 60, 108. So that's what you would really want to see, those type of numbers across your carbons or graphites or lamp black people use, whatever. Okay. But I was going to see if this is coming down. It will, because I've done heaps of coils in it. It suddenly didn't go non-conductive overnight. Oh God, this is ridiculous. 200k. Oh, there we go. If you look at that now, it's sitting there at 38,000 ohms. All right, 38, 40,000 ohms, near enough. But I will. I'm going to hit it with a hot air, just lightly. I'm not going to go and blast it 400 degrees or anything like that. Whoops. Is that 186 or something degrees Celsius? But I'm miles away, and there's not a lot of airflow. But as this dries, it will definitely go a lot lower in resistance. If you want to be really smart, you could actually put a wire onto this after you paint it, and another wire onto the paper shield over the top, so you'd have a sort of like a double sandwich Faraday layer. It will increase the shielding doing that. That's been proven. And to tell a little funny one, I paint the bottom of my skid plates in black conductive carbon. Got any idea why I do that? I'll leave that as an open question. So we'll see where we are now. I probably haven't dried it much anyway. Oops, there we go, 0.02. Hang on, let's see where we got to. So, oh, come on, it's still above 200 ohms. I'll put it on 2K, a little bit drier. There we are, 400 ohms. So we've gone from 40K to 400 ohms. As it dries, it'll go lower and lower and lower to all the moisture's out of it. This is a water-based product, by the way. It is not a solvent-based product, and that's probably a good thing. So, okay. If you can see, I can't see the meter there. I don't want to put the meter on the soldering iron. There we go. Go over there. If you can see that, let me have a look. Where are you? Oh, you can see that easy. I had to stick my head back around. Okay, so we're on 2K ohms, and there we go. So there you go. It's 500 ohms or something there. 480. It'll go down and down and down as time goes on. So it's basically where I probably dried it the most. It'll go down 470, 460. Oh, it's bouncing around. Yeah, 4.6, 4.5 something, 4.4. As it dries, it just goes down. So you want to end up with something exactly more or less, 80 ohms, 60 ohms, 50 ohms even. It's probably getting down low, but we did see on that X coil, that was somewhere 10 ohms across the whole thing. Now, that's interesting, isn't it? That people rave about it. Maybe that's a factor. 10 ohms. It's very low. Uh, I don't know why that would work so well with such a low resistance Faraday shield. But anyway, that's what it is. So what we do, we get on here. Oh, we're down to 300 ohms now, so it's dropping away. It might take half a day or something to properly cure and um, do its bizzo, but you get the gist of it. Now, what I was going to say, you got to think this out. You do not want to paint over the windings, get paint in the windings here. You want to definitely, like, you can just use big elastic rubber band type things and stick them in there. Don't come out too far because it'll be spongy. But, and then away from the windings, you could smooth it off. You could use, dare I say, silicon, wet finger, smooth it off. Keep it in the windings. Don't get it on here. Don't get it on the foam. Just, you want to keep everything locked in, but you don't want silicon hard on the windings. You want to space it. Even rubber bands is a very bad dielectric. Rubber's got a really high dielectric. You don't really want to do that. So you got to think of something. If you're not going to get water in your coil, I would wind it in cotton because cotton has a dielectric very close to air dielectric of 1. You could probably, I have never done it. You possibly could use wool. I don't know. I've never measured the dielectric of wool, but say that was all flush anyway. Whatever you put in there, you could put strips of paper in there if you really wanted to. But got to remember, if it's hydroscopic, it's going to suck in water. You don't want that. Maybe, uh, you know, I'm just trying to think what you could actually put in there. Don't put Teflon in there. That's triboelectric. It'll cause staticky noises. It'll ping when you bang it. What else is there? Polypropylene is really good, but I don't know how you're going to do that. Can you get polypropylene string? It'd be slippery as hell too, and I don't think you can glue to it. Maybe, I don't know. What about, I'm thinking here, something like if you get plasticky nylon shoelaces, something like that. Actually, go to the hardware store and get that um, polyethylene, the thin stuff they use for draw strings on Venetian blinds, stuff like that. Something like that you could wind in there and you could lock it in place fairly easy. You got to be careful what you put near the windings. It will impinge on the performance. It maybe a little bit, but it's still going to do it. So you just want to avoid doing bad habits like that because you eventually say, oh, that's an easy way to mount the coil and I'll do the whole thing in a big blob of that and it won't work very well. But when you come to here and you've got to come up here, what I would do, I would paint the top edge. This is the top of the coil. Paint the top edge here. I'm going to do it because I set it the wrong way. Don't do that. You get paint everywhere. But yeah, here, paint the top there. And the best way to do this, I'm touching it, yuck, is keep the brush very flat. Just there on that lip, okay? That's not much paint on the brush now because it's starting to get a bit dry. I better get some water on that so I'll lose my brush. And on the other side, when you paint it all, paint around here as well. And just get masking tape and put the masking tape so it overlaps the bottom of the coil a little bit and just comes up on that edge there. Now, if I had masking tape, this is how I would do it. It's a masking tape exactly like I'm doing here. and because it wants to go in the gap, of course, because they haven't got it filled, don't make a mess out of it, along like that. So that would fold back under. Don't paint this to that. Do not do that. It will cause a big short circuit on the Faraday shield. You don't want that. You want this, if it stays over, maybe you get wider masking tape, doesn't make any difference. And you don't want it bulgy. You want it to be on whatever it's in here. Keep it flat and paint, dab it there to this when it's got the paint on it. So it's conductive onto that, but stops. It can't go onto here because there's no paint on that. So it's not going to connect. And just make sure you don't do anything and pull the paint over and make a thing. You can, before you put the wire through, you can check it with a multimeter. If there's any continuity, go through, and whatever it's doing it, knock it off. Just remove it and make sure you have no continuity between this painted side and that painted side. Let it all dry so you know it's perfect. Then you put your wires through. So you join this with half of this thin wire here, poke it through the hole, and do the other side here. I'm going to knock this stuff off too. I'm going to paint it. You don't want to paint over this because what will happen, the high points will rub on the coil shell and wear through, and you'll lose your Faraday shielding. Make it all smooth. Make it smooth. Dig it out so it's trenched. A trench can't rub on anything, and the big flat side here is not going to make any difference. So you can do that, and if you want, you can even throw your cardboard bits back in there, or you could put anything in there really as a spacer. I'll tell you what would make a really good spacer, and I'll show you right now. I've got to reach under here. It's the stuff I actually used, this stuff. Now, if you buy anything from AliExpress, usually it comes in this foamy stuff, right? It's like a polyethylene foam. And if you can find this, it's very thin. If you can find that and stick it to your coil and use it as a buffer, right? It'll never wear in a million years. This stuff, because it's air, got air through it, it's not an impediment to anything. And if you could find that thick enough, you can make a coil out of it. It probably wouldn't be stable enough, but think about it. There's a lot of air in that. Actually, thinking of that, guess what I would do with this? I would get a guillotine or some way of cutting strips, and I would see, it all comes to me as I'm doing it. And I've probably done this before but forgotten about it. Shove it in there. That is beautiful. Shove that in there, put multiple layers in there so the gap is flat. So here's my little target stick. So you want to come up just in that. Oops, I'm way up there, sorry. You want to come and just fill that gap in there, just that gap near the white windings. Fill that with whatever, and then mask on top of it. You could probably just put a whole thing of masking tape right around to itself, and that'll lock that in position, because masking tape, once it's on, it won't fall off. But you don't want these windings to move. If they move, you'll get the wee-oo, right? And if you tap it up against sticks, objects, rocks, and that, it'll sound off and it'll drive you crazy. You've got to lock the windings in. They've got to be locked in, and you want to do it using the lowest dielectric material you can. And I'll tell you, just looking on my bench, I have this double-sided fluffy tape, right? And this stuff it's really sticky. Okay, this is a sticky foam. You can use it for putting circuit boards down and stuff like that, because it's sticky both sides, which is probably not what you want for this. But then again, if you cut it to the size of the gap and put it in here, cut it down the middle and make strips out of it, it will stick to itself and you'll never get it off. And if you do use a double-sided, you could finish it off with a band of masking tape around it, because the masking tape would stick to this like you got no idea. Let's have a look. Look, you got to prove it. So here's a masking tape. I've got it on the sticky side of my finger, and I'll put it on there. Do that, and I'm pulling, and that is really stuck hard. Look at that, it's going to pull the foam apart. That's a really good way to do it, guys. So the other side of this is obviously you take that off as well and get it in the gap and stick it like that. That's awesome. That's really good. Look at it. It actually pulled the foam off. So that's how good it grips. Perfect. Beautiful. I'm going to be doing that on my own coils from now on. And it sticks really well. It really sticks. It's really tacky. So it's a foam. It's a foam material. Um, and I would say, if you want to measure the dielectric of this stuff, what I do, I usually cut 1 centimetre squares. I have 2 metal plates, and I measure the capacitance with air, and then I put my materials in the middle of the plates, and then I measure the capacitance, and I can work out my dielectric constants. So it's not a laboratory standard type um, result, but if you got air in there and you say you set it, say you got five picofarads, right? And you put some material between it, and it jumps up to 20 picofarads. You'll know it's got a very high dielectric. Don't use it. You're better off getting something you put in there, and it's like goes from 5 to 6, or doesn't even moves even better. But you can do that with a capacitance test. Yeah, that's how I sort of know what to use and what not to use, because not everything is documented for its dielectric constant. So that's dried a little bit now. Let's have a look. I've buried my multimeter leads, so we'll see what we're down to. Oh, look at that. We're getting around to the mine lab territory on that, aren't we? No, a little bit high. Oh, 40 there. 40 at a centimetre sort of thing, maybe a little bit more than a centimetre. There you go, 60s. So that's perfect dielectric. Sorry, resistance, carbon or graphite resistance to make this thing work really, really well. Just make sure you just do all little nooks and crannies and tape it, and that goes there, goes down a hole, wherever the hole is there. I think it was, no, not there. It's off on the side because that's where the cable went through. Did it? No, cable went through there. And we got 2 holes here, so I remember rightly. There, down there, and it laid back here, and there's a hole. One of the holes is that one there. There we go. That one goes right through. So yeah, just lay it off, and then on that side, dab it down with this stuff, the black gunk, the HFS modified SF 54, and there you go. That's the basis of doing it, and then look at the previous video for placements and the amount of solder to put here. Masking tape over here, masking tape over here. You could paint the cavity in here, but because you've got the wires here, it's what are you Faraday shielding it for? Something that way? It's already got a Faraday shield. Don't do that. You don't need to. It's going to add capacitance to the windings, or to the wires, which are part of the windings. I'm just trying to call out every trick and every trap on doing this, but yeah, you could put some of that, squeeze that in there if you want. Put tape over the top and just make sure it's all tack painted, so that masking tape's painted and it's conductive to here, all the black stuff should I say, and just go over the whole lot. Just don't let anything that's metal look at the ground. It's got to be blinded by the black stuff. That's how you look at this. It has to be blinded by the shielding. And if it's blinded by the shielding, you can't have any ground interaction with the coil windings or any part of the structure. Even around here, if this is not covered properly, and that it will react to the ground, and you'll get that ground balance offset, and you'll hate it. So that's a really easy way to resurrect a coil. And I said, you could go into business doing this if you wanted to. you'll get work. If you advertise for it, you will get work, and you can sit there all day fixing coils for people. You know, fixing up $3,000 X coils if they have issues, they come apart. Well, that's why this X coil I've got here, wherever it is, that heap of paperweight. Oh, God, it's heavy, right? That's why I've got this. It failed, okay? The guy said it failed. It became noisy and intermittent. So there are failure mechanisms. I don't know what it was because, like I said, I didn't pull this off. It could have just been a broken wire, the shielding come off, and if you actually get it to a point like that, you could have fixed it. I can still fix that. I can make that work. It's not a problem. It's easy because it is what it is. You know, I can get to the end of the wires and things. I can, put those, put these back in. Not that I really want to, but yeah, it's simple enough. The only hard bit about this coil would be where it's got the Faraday shield here. It's painted on the plastic housing, and this is glued onto that housing. And you'd have to. I tried getting it off. Like you can see that bending, right? It will come off. You would have to make a tool, like I'd say something along the lines of um, a a bent 90-degree type bent butter knife that you could just get an end up, get it in there, and just work it around. You can repaint the shielding. That's no problem. Um, there's only foam on the other side, and you gouge it in a few places. It's not going to do anything. Uh, you can you get to know things after a while. And if you had a detector, you could put it on and test it, and just see. Basically, if you can get it quiet enough in your house, or somewhere away from interference, all you do is when you got your coil, just put your hand on it like that. If it sounds off on your hand, you know you've got a problem. If it doesn't, you're probably right. So that's that. Well, that's a lot of waffle about doing this. It really is simple to do. It is not difficult. I could easily teach a 10-year-old to do this, and it would be spitting out like sausages. Not that I would do a 10-year-old doing this with a sharp knife, but I'm just giving an example that it is not difficult. It's not magic. It is just a practical approach to putting a winding in, keeping the make the like we all talk about Q in windings. That Q means quality, right? It means that it's it's not to get high quality in a coil. You basically got to keep the capacitance out of it, but you got to keep enough magnetic coupling between the winds. It like I gave the formula for that in about 3 or 4 videos ago, but I've tested that. It works, by the way, and that came out of the University of Surrey magnetics department. If you really want to know, and yeah, I'm going to be really nitpicking if I try and explain things anything past what I've done. Uh, you can see it's a little bit silvery there. That's because the multimeter leads touched it. You touch this stuff with metal, it silvers. Like if I probably went like that, I don't know if you can see it, but see it just changes a look, and it goes silvery. Doesn't hurt it at all. Doesn't increase the or decrease the resistance or anything. It just goes silvery. Just don't gouge it out. But that's people look at it, oh, you missed a bit or something. No, it's not. It's just what it is. So this would be good. Like I say, you could get something like this foamy stuff that AliExpress uses packing wrap. I've had so much stuff come in this, and I think you can buy rolls of it. It's full of air. It's beautiful stuff for doing a padding between that and the coil bottom. And if you did that, padded it, and it's very soft, you're not going to get all that carbon rubbing off everywhere, right? Because eventually it rubs through and you've got a noisy coil, and you'll just, like a lot of people do, get the coil and throw it in the bin after you spent $400 or $500 for it. It's not really smart. Fix the things. Like I showed you how to get it apart in the other videos. Do it. Fix your coils. Don't throw them out. And if you want any, like even if you want Litz wire, like I said, I've got 600 odd kilos of Litz wire. It's exactly the same stuff as this. Actually, mine, looking at this, mine has more strands in it, thinner, so it'll work better on the faster machines. If you're going to use very fast modes like enhanced mode on the L4500s and that, and like I say, if you're going to use dongles, there's nothing stopping using these on 6000s. And if you want to get really complicated and do it, you can do it. You can make your own 7000 coils if you're going to dongle it. There's nothing stopping you doing this. The only trouble with the 6000, of course, where does the dongle live? In the coil. Uh, if you carefully remove that dongle out of the coil, you could then mount it up. You can actually put it in the detector for a handshake, and then just run any damn coil on it you want. That's how I do it. My thing is, I love getting around when people do things to thwart you doing something, try to stop you doing something, and forcing you in a direction. I love rebelling against that, and I go against it, and I say, "Oh, I can get around it doing this and do that," and I get around it, and that's basically, some of my thoughts on all this stuff. Good on them. They're doing what they want, and like I say, everything is in my own personal opinion. Hope that's very clear. It's just an opinion. It's not. Nothing is scientific fact, is it? No, just an opinion. But anyway, you know what I mean. You can also, like, come here, you. Well, you see how Nugget Finder have done their coils, right? This is a 12-inch advantage, and I think from memory that might be masking tape just there. Probably tacked down one side, not the other. I don't know. I actually haven't measured it. But what I did here, I don't know if you can see. I'll explain something. When I was saying that the whole thing is a big mass of carbon, okay? It's a big mass of carbon. That it acts as a Faraday shield, but it also is interacting as a resistive load on the winding. So if you see here, at one point in time, I did an experiment. I cut the foam around the winding here. I actually cut it and isolated it, and I did before and after measurements by putting tape across it and earthing the tape here with the black Y shield paint, and just having it over here, but not reconnecting. So I had a break, as it wasn't a complete shorted turn. It was no longer a short on the coil, and I'll leave it to your imagination to what happened. But that was just an experiment, and then I wanted to use this as just a test coil, just in here, as a reference coil. And I just put various cables on and whatever else I wanted to do. And yeah, I just rejoined that up because I can't use something I've made as a reference against other things. Well, I can, but I wanted bog standard reference. So that was a reference coil. And we'll get on to here. Sorry, there might be another long video. I don't know how long it's been going for. I'm just having a look, 49 minutes. So with a double D2, this is this softer. Well, that's soft. You can push it in, but it's still good. You could paint all this as well. It's very close. I don't like it because it's close, but the paper on here, when it's carbon painted paper, is close as well. But what you could do, you could just get masking tape, and I wouldn't do masking tape long ways on this. I would make it like this and just stack layer it across the whole thing, make it tight. It's probably not much of a gap there that masking tape is going to move once it's painted. It might end up being very well. Actually, I've done it. It's quite stable. It's fine. There's nothing that's going to push in here and move it. And in here on the receive windings, you could do the same. You could just get masking tape, and you could put it probably on that. You put it long ways, and around you go, masking tape, and just paint the whole thing with the black shielding paint. As you can see, I've had a play with this one, but you can do that, and around there, paint the whole thing, and you really want to keep an overlap join, or like if you're shielding over there and just come over, but don't paint, have this painted, but don't join that to that. Just have it on the bottom of the coil. Oh, by the way, I should say this, on the bottom of the coil, always have your continuous carbon or resistance up on the bottom of the coil. Don't do it on the top of the coil because it'll sound off, right? You protect like that. Bottom of the coil and up. But don't join it to this. Just have this done for fine wire, each side onto your carbon paint. Dab it on, thicken it up so it doesn't move, or you can tape it down if you really want to. There's many ways of doing this. No way's better, or well, there are ways that are better, of course, but as long as it serves the end game, I suppose. I would just do things differently than other people. That's all, because I just do a lot of research into it, and I talk to a lot of very, very smart people. So we confer, we discuss, various aspects, and I'm just an information sponge. I probably forgot more than what I've learned, but that's how you do it. And maybe I'll do the whole thing. I'll put it back together, and I'll show you how it looks like when it's all together, and then we'll go out and do a test. I've got a commander coil, right? I'm going to make this a really interesting test for everybody. Now, commander coil, 8-inch commander coil, okay? Now, these were said to be a better coil than any other coil. Remember all the hype about commander coils. And this is an old GP, whatever it is, that thing. What is it? It's a gold surge. It's super gold surge. It came out with GPs or something. It's old. It's old technology. So we've got the newer technology here. What we're going to do, we're going to put the one I refurbish up against this, right? We're going to do some depth tests. We'll do all sorts of things. Noise tests. We'll see how well it ground balances. We'll do all these tests and we'll see which one works best. So that's fair enough. It's 8-inch. It's got it measures the same. It all measures exactly the same. Same resistance, same amount of microhenries, probably the same turns ratio. It has to be, and we'll see how we go with that. But that's going to be very interesting. That's going to be. I'm going to do more of a scientific one on that. I'm going to do it properly, we'll see how it goes on just terrestrial noise as well. I'm going to purposely get this coil detector arrangement near houses, power lines, businesses, industrial, and we'll just be doing swap overs and see which one has the least noise and does it still perform the same or better or whatever. We'll just see that because, has anyone done it? No. So I'm going to do it and we're going to test it. So I know it's a slow process. I've only spent a little bit of time on this. I've got tons of other stuff I've got to do. I've got to get detectors out for people. I've still got to do sevens, and I've still got a couple of GPXs over there I've got to do. I've been working like crazy trying to get it all done. But this is the coil thing. And like I say, there is a business opportunity fixing coils for people if you really want to do it. If you haven't got a job and you want to do something, I think it's staring you in the face. So how much would you charge to fix a $3,000 coil? I'll leave it up to you to think that. And even repairing one that's, is worth, $400, $500 or $600 or whatever. Yeah, there's good money in it. Believe me, what do you want? Working coil or something you throw in the bin? Go and buy a new one. If you can save money and fix it, and in some cases you can probably make it better. As time goes on, when you do this stuff, you'll learn. You'll go, oh, I did this and that didn't work. Oh, I did that. Oh, that worked fantastic. You'll get to know, and then you put it into your own coil designs or your own work on it, whatever. like I say, don't be scared of making coils. It's, you know, it's, as long as you know the pitfalls, you will make a pretty good coil. Just, just listen to exactly what I said. If you do exactly like I said, all your coils will work first go. They'll work beautifully. There's no problem. So I'll just, final thing, we'll just check the resistance of the Faraday shield, because I've been yabbering on for so damn long. I know people say I yabber on, but I can sit here with my mouth shut. Come on, behave. Oh, get on there. Okay, right in close, about a centimetre. We're down at 33 ohms. Spread it out a bit. 36. Yeah, 55, 60. That's going to be a well shielded coil, and it's probably because I put 2 layers of paint on it. When I was saying I wasn't getting a resistance reading, I just layered it up again. Don't have to do that. Anyways, there's more stuff about applying the Faraday shield. I'm going to get into in another video. There's reasons for everything and getting performance increases out of coils. That's your ears to your gold nuggets. You want to make sure they're nice and clean and can hear everything, right? But anyway, that's that. Catch us later.